Hey there, science fans! Today we're diving into the fascinating world of moles. No, not the furry creatures, we're talking about the mole concept in chemistry. So what exactly is a mole? In simple terms, it's just a unit of measurement. Just like we use dozens to count eggs, we use moles to count tiny particles like atoms and molecules. Think of it like this. A dozen always means 12, right? Similarly, one mole always represents a specific number of particles, and that number is huge. But why do we need such a big number? Well, atoms and molecules are incredibly small. To measure them in practical quantities, we need a unit as large as a mole. Now let's talk about that giant number I mentioned, Avogadro's number. This number is so important that it has its own name. Avogadro's number is 6.022 times 10 to the 23rd. That's a 6 with 23 zeros after it. It's mind-bogglingly large, but trust me, it's crucial for understanding moles. This number tells us that one mole of any substance contains 6.022 times 10 to the 23rd particles. That's true whether we're talking about atoms of gold, molecules of water, or even grains of sand. So why is Avogadro's number so big? It all boils down to the tiny size of atoms and molecules. To work with them in meaningful ways, we need a unit that reflects their incredibly small scale. Now that we understand moles and Avogadro's number, let's talk about molar mass. This concept connects the microscopic world of atoms to the macroscopic world we experience. Molar mass is simply the mass of one mole of a substance. It's expressed in grams per mole, g-mole. We find it on the periodic table. For example, the molar mass of carbon is 12.01 grams per mole. This means that one mole of carbon atoms weighs 12.01 grams. Similarly, the molar mass of water, H2O, is 18.02 grams per mole. Molar mass is incredibly useful in chemistry. It allows us to convert between grams and moles, which is essential for many calculations and experiments. Get ready for some math, everyone. Don't worry, it's not as scary as it sounds. Converting between grams, moles, and particles is a fundamental skill in chemistry. Let's say we have 24.02 grams of carbon. How many moles is that? We can use the molar mass of carbon, 12.01 grams per mole, to find out. 24.02 grams of carbon times 1 mole of carbon over 12.01 grams of carbon equals 2.00 moles of carbon, see? We just used a simple conversion factor to go from grams to moles. Similarly, we can convert between moles and particles using Avogadro's number. These conversions are crucial for stoichiometry, which we'll discuss later. For now, remember that moles provide a bridge between the macroscopic and microscopic worlds of chemistry. Section 5. Representative particles. Tiny building blocks of matter. When we talk about moles, we often refer to representative particles. But what exactly are these particles? In simple terms, a representative particle is the smallest unit of a substance that still retains its chemical properties. For example, the representative particle of an element is an atom. For a covalent compound like water, it's a molecule. And for an ionic compound like salt, or NaCl, it's a formula unit. So when we say 1 mole of water, we mean 1 mole of water molecules. And since 1 mole always contains Avogadro's number of particles, 1 mole of water contains 6.022 times 10 to the 23rd water molecules. Section 6. Formulas everywhere. Empirical versus molecular. Hold on tight, because we're about to delve into the world of chemical formulas. Don't worry, it's not as complicated as it seems. In chemistry, we use formulas to represent the composition of compounds. There are two main types of formulas, empirical and molecular. The empirical formula of a compound gives the simplest whole number ratio of atoms in the compound. For example, the empirical formula of glucose is CH2O. The molecular formula, on the other hand, tells us the actual number of atoms of each element in a molecule of the compound. The molecular formula of glucose is C6H12O6. Knowing the difference between empirical and molecular formulas is essential for analyzing chemical compounds and understanding their properties. Section 7. Stoichiometry balancing act in chemical reactions. Now it's time to talk about stoichiometry, a fundamental concept in chemistry that deals with the quantitative relationships between reactants and products in chemical reactions. Think of a chemical equation as a recipe. It tells us the ingredients or reactants and the final dish or products of a chemical reaction. Stoichiometry allows us to predict how much of each reactant we need and how much of each product will be formed. It's like balancing a chemical equation. One important concept in stoichiometry is the limiting reactant. This is the reactant that gets used up completely in a reaction, limiting the amount of product that can be formed. Section 8. Molarity, measuring the strength of solutions. Have you ever wondered how strong a cup of coffee or a glass of juice is? In chemistry, we use molarity to measure the concentration of solutions. Molarity, often abbreviated as M, is defined as the number of moles of solute per liter of solution. A solute is the substance that gets dissolved in a solvent to form a solution. For example, a 1M solution of sugar in water means that 1 mole of sugar is dissolved in 1 liter of water. Molarity is a crucial concept in many areas of chemistry, including acid-base chemistry and titrations. Understanding molarity allows us to prepare solutions of specific concentrations, which is essential for various chemical experiments and applications. Section 9. Wrapping up the mole concept. Key takeaways. Congratulations, science explorers, you've journeyed through the world of moles, from Avogadro's number to molarity. Let's recap the key takeaways. 1. A mole is a unit of measurement used to count tiny particles like atoms and molecules. 2. Avogadro's number, which is 6.022 times 10 to the power of 23, tells us the number of particles in 1 mole of a substance. 3. Molar mass connects the mass of a substance to the number of moles. 4. We can convert between grams, moles, and particles using conversion factors. 5. Representative particles are the smallest units of a substance that retain its chemical properties. 6. Empirical formulas give the simplest ratio of atoms in a compound, while molecular formulas give the actual number of atoms. 7. Stoichiometry helps us understand the quantitative relationships in chemical reactions. 8. Molarity measures the concentration of solutions in moles per liter. Section 10. Keep exploring the world of chemistry. The mole concept may seem daunting at first, but with practice and a little curiosity, you'll master it in no time. Remember, chemistry is all about understanding the world around us at the molecular level. Keep asking questions, keep experimenting, and keep exploring the fascinating world of chemistry.